The step of applying input space partitioning is as follows. So you have two tasks. Task one is when you model the input domain, and task two is when you choose the combinations of value. So let's start with the first one. You start with identifying the testable function first. Okay, what is the function being tested? Okay. Next, you understand a few things. So you understand what are the parameters, what are the return types, what are the return value of that function, and what is the exceptional behaviors. Next, you do the input domain modeling. This is the most creative part in input space partitioning, and you need to use your creativity, understanding of the specification, and some test case design skill. So after that, you get into task two, which is you apply some test criterion to choose the combination of the blocks. So this will generate the combination of test case values that you would get. And the last one is you would derive the test value. And finally, you would get the test cases ready for performing the test. So in the first part, we're gonna mostly discuss about the task one, which is modeling the input domain. So as I already told you, the domain is scoped by the parameters, okay? And we're gonna focus on these parameters to generate our test case input using input space partitioning. We need to create characteristics, okay? So characteristics are the things that we use to define the structure of our input domain. And we will use it to partition the input domain into blocks. There are two approaches that we can do. We first can use interface-based technique that we will and the second one is the interface-based technique, which is slightly more difficult, but it gives you more better test cases. We're gonna develop the characteristic from the behavior of the program or the function that you are testing. So the steps are as follow. You first define the characteristic. Then you partition each characteristic into blocks. And then you identify the value of each block, or you find the representative. Okay. So the characteristic that I mentioned, they have some differences. So for interface based, we develop the characteristic directly from the parameters value. Okay, so you just translate the parameters that you have into the characteristic. It is pretty simple. You just need to understand what are the parameters, what are the data type, and what are the value that they can be. So you consider them separately as well. So each parameter, you consider each one separately from the others. So you rely more just on the syntax of the program. And you don't think about the domain or the semantic information of the program. And you don't care about the relationship among the parameters. This makes the interface-based technique simple, easy to do, and straightforward. Sorry. So the next one is functionality-based technique. So functionality-based technique, you develop the characteristic based on the intended functionality of that function or that program. And this one, you can use relationship among parameters so that you can create better test cases. You try to understand what are the relationship. And then you can also include the domain and semantic knowledge. You understand the spec, you include that into the generation of test cases as well. So you might get a better test, and you are not restricted that each parameter is considered in only one characteristic. So one parameter can appear in multiple characteristics as well. All right. So when we try to apply this, we need to partition the characteristics. So when you partition the characteristic, you get a set of blocks. Okay. And the set of block will represent a set of values in that input domain. So if you get more blocks, that means you get more tests as well. And lastly, the partition, you need to make sure that it satisfies the two property of disjointness and completeness. So finally, it is better that you have more characteristic with fewer blocks. Because if you have more blocks, you can potentially make more mistakes. Okay. So if you have more characteristic, but each one has fewer blocks, you can have fewer mistakes, and also you have fewer tests. So how should we define the partition, and how should we select the representative value for each partition? We're going to discuss next. So to identify the value from each of the partitions, you can use your intuition or follow some of the following guidelines. You can include some valid value, invalid value, and special value. You can subpartition of the block further to make it even more fine-grained. You should consider the boundary of the domains, just like the concept of boundary value analysis. So when you partition them, try to select some value at the boundaries between the partitions. You should also have some value that represent the normal use, or what we call a happy case, the one that's supposed to give the correct answer. And you should balance the number of blocks in each characteristic so that there are not too many blocks. And finally, you wouldn't get too many test cases as well. And lastly, you check for completeness and disjointness. Okay. Once you have defined all the blocks, you can choose any value, or you can follow the strategy here. But anyway, each value that you choose should be equally useful for testing because they belong to the same block. So let's come back to the example that I gave before. So if we have this method called getIndexOf, we don't need to see the source code of the method too. We just need to see the spec and the header of the method, or the interface that we need to test. You know that this method is called getIndexOf. So when we identify the testable function, we know that it is getIndexOf function. We want to identify the parameters. So looking at the interface, we would see that there are two parameters, string and letters, and letter. The return type is integer, okay? And the return value depends on the spec here. If it finds the letter, it returns the index of the first occurrence of the letter. If it cannot find, it returns -1. So we list the return value here. And in this case, there is no exceptional behavior. So how do we define the characteristic? First, we're going to use the technique called interface-based technique. So we just care about the parameters. We consider each of them independently, and then we try to create partition out of that. So we have two parameters, string and letter. So we also define two characteristics. The first one, C1, we define the characteristic as string is empty. And let's see, if we use this characteristic, we can create two partitions, B1 and B2. So for C1, we say a string is empty. So we have two partitions. First, the string is empty is true, and the second partition, the string is empty, is false. So this would represent the case where the string is an empty value and the other values. Okay, so in this case, you have two blocks. The second partition, the second characteristic, we say C2 letter is empty. So similar to the previous one, if we say the letter is empty, we can have first block, letter is empty equals true, and the second block, the letter is empty equals false. So next, let's consider whether these partitioning satisfy the two properties or not. The first one is, does it satisfy the completeness property. Let's pause the video for a minute. Think about this completeness and then resume when you are ready. Okay, in this case, we will see that the characteristic C1 is the partition of characteristic C1 is complete because block B1 and block B2 cannot have any overlap. If a string is empty, it cannot be non-empty. And the other way around, if a string is non-empty string, it cannot be empty string. So we satisfy the completeness property for C1. For C2, we follow the similar logic. If a letter is an empty letter, it cannot be other letters. And on the other hand, if the letter is non-empty letter, it cannot be empty letter at the same time. So we satisfy both C1 and C2 for completeness. Next, let's move to disjointness property. You think about it for 1 minute and then resume the video. Okay, what do you get? We will see that when we do disjointness, we want to check whether if we combine the two blocks together, would we get the whole input domain of the parameter back? So for C1, if a string is a parameter and we have two blocks of a string is empty is true, which is an empty string, and a string is empty is false, which is a non-empty string. If you combine the two blocks together, you would regain back the value of the all string possible value, which is empty string and non-empty string. So for C1, the disjointness property is also satisfied. And for C2, we again follow the similar logic. If a letter is an empty letter and you have another block of non-empty letter, if we combine them, we would get the whole value of the letter back. So this also satisfies the disjointness property. So that is the second step. We partition the characteristic and then we check for completeness and disjointness. So next, we're gonna start identifying the potential possible value. So from block B1, empty string is true. You can select only one value, which is an empty string. From block B2 of C1, if a string is empty equals false. So you can select any string that is a non-empty string. And in this case, I select the string testing. Moving on to C2, the first block of C2 is a letter is an empty letter. So I can pick only an empty letter here. And the second block is a letter is empty is false. So I can pick any letter. And in this case, I pick the letter T. Okay. Then we move to task number 2, which is choosing the combinations of the value. When we have the number of blocks, usually we multiply them and then we got all the combinations. So in this case, we have the first block C1. The first characteristic C1 has 2 blocks. And the second characteristic C2 also has 2 blocks. So the total amount of tests that we have will be 2 multiplied by 2, and we get 4 test cases. The 4 test cases include when the string is true and when the string is empty is true, and the character is empty is true. The second one is a string not empty, but the letter is empty. The third case is when a string is empty and the character is not empty. And the fourth case is when a string is not empty and a character is also not empty. And next, we would test whether there are any redundant tests or infeasible tests. But in this case, there is no redundant and there is no infeasible test. So we finished the final step by deriving the full test value. So for each of the test case that we define, so T1, empty string, empty letter, we come up with an expected result, which is -1. If you find an empty letter in an empty string, you cannot find anything, so you return -1. For T2, you have an empty letter but non-empty, empty string but non-empty letter. You cannot find a T in an empty string, so you would expect to get -1. For T3, you have non-empty string but an empty character or empty letter. You cannot find the letter that is empty in a string, so you return -1 as well. And the last one, you have non-empty string and non-empty letter. You want to locate the location of letter T in this string, and you would find that the index of the first occurrence is at 0. So the expected result is 0. Okay, that is all about input space partitioning using interface-based technique. Okay, I hope you are following. So let's move to the next one.